Alright, CNT140, we're looking at Chapter 6 on our video system installations. So again, this is kind of one of those familiarity things. We may or may not have to deal with this down the road, but at least a little bit of familiarity is helpful if you have to deal with anything related to security cameras or cable TV in a building. So the two main video applications they're going to talk about is just that: your closed circuit TV for security and your television or your cable TV, if you will, community antenna TV. But all these are going to require coax cables for transmission. Eventually, a lot of these things are slowly migrating over to twisted pair. So some of this is fading out, especially inside buildings. But again, familiarity is the key. They're going to use various types of coax cable. So I tried to give you a picture here to show you roughly the size differences. The book starts talking about blah coax cables used for this and blah coax cables used for this. This gives you a little idea then. So when they start talking about RG11, RG8 up here, RG11, RG8 were used for trunk lines, that gives you an idea of the size of coax cable. And then when going into houses, you start having things like RG8, RG58, RG59. Going into houses, you get an idea of the size differences. That's why I put this picture in here. So first thing they say is RG59 can be used for distances under 1,000 feet. This is the kind of thing used in your house. That's what this down here, the rather small one. RG11 should be used for distances 1,000 to 2,000 feet. Yeah, this is the one being used as like trunk lines that your coax, your cable TV provider is doing for you. And then RG11, RG8 for trunk lines, and RG6 for drops. Yeah, I just kind of threw all that in there for you. For installation, they remind us about if we're installing coax cable, not pulled beyond the tension limits and not bent sharply. This is the same thing we talked about with twisted pair. I start pulling on a cable too much, I start affecting the inside structure. So as I'm pulling, I'm doing, one person's installing it, the other one's guiding it out of the box or off the spool or anything like that. And as these are routed in through a building, going around corners, nice gentle bends around corners. Try to make a nice gentle arc going around the corner. We need to make sure, the cabling stays away from any possible areas where the cable can be damaged, cut, bent, or cut, scraped, anything like that. Keep away from hazard areas. They remind us about if I'm bundling or strapping the cabling, I need to take care as to not damage the insulation or the shielding inside. They also remind us about cameras. If I have to deal with cameras, they need to be firmly mounted. Again, a lot of security systems are moving over to IP security cameras, IP security based security cameras, so they're going to be supported with unshielded twisted pair cabling. Just as a little side note. Termination for coax. Typically we're going to use either a BNC connector for closed circuit TV or an F-type connector for most other coax uses. So for these, we need to make sure that the shielding and the center conductor are handled appropriately. So they remind us that compression connections are preferred and the cable itself should be good quality. And here they give you this chart in the book. It's kind of okay. F-type and BNC are the ones you probably encounter the most. So I put those two in pictures here for you so you can see. Here's your BNC type connector for closed circuit TV. Here's your F-type that you would have for your cable TV and or if you have a coax coming into your house for internet connection. That's typically the type of connection you're going to have. And they remind us for termination of this guy, and this actually isn't too bad of a picture. The steps are roughly, you use your coax stripper to cut off the outer jacket, the shielding, and the inner dielectric here, so you expose the copper conductor. I cut it one more time with my stripper using like the next setting where I cut off just the outer jacket. I roll back my foil shielding, slide my connector on, and compress it or crimp it into place. And the actual copper wire the connector out here is exposed. So I have this. That is the actual wire going down the middle. That is what makes connection as you are screwing it into place. Okay. They then remind us that in my National Electrical Code, the 820 is the part that specifies all the requirements for the coax or coax supported systems. First provided television signals communities could not receive broadcast. Yep. If we think back to early, most people had antennas on their house. If you didn't get good signals, your cable TV company would have the head end. If you remember talking about that previously, you have the head end with a bunch of satellite dishes. They would pull in the signals, encode them, ship them to your house across the coax. So first, television signals were provided for people that could not receive broadcast stations very easily. Community antennas were installed and signals were fed to homes. Yep. Later, signals via satellite broadcast became common. Yep, exactly. All those things we had mentioned previously. The demand then became enormous as people started buying into cable TV because they could get channels, special ESPN channels, that sort of thing that they could not get through their antenna. So then the cable television companies began providing service based on your giving you coax, that sort of thing. Became widespread use, absolutely. So with that, 820 covers all the radio frequencies sent through coax cable. It does not cover anything else that's not using coax. So this is just the coax cable. The primary safety requirements is making sure the voltage levels across there does not exceed 60 volts. It's not meant to really carry any kind of current, just enough of a signal for the television signals coming to your house. Power source must be energy limited, absolutely. And they do need to worry about grounding, particularly as that coax cable comes in from the telephone pole to your house. That piece needs to be grounded because of surges and lightning storms and that sort of thing. And I think I have in here a reminder on the next page or two. Here is, I'll go back in a second, but here's that grounding schematic I showed you before. Cable TV connection coming off that is a ground wire going to the ground rod that you have at the side of your house. So that needs to be grounded. And they remind us that cable must be grounded as close to the building's entrance as possible. Yep. Connector must be insulated. Yep. They give us a 14 gauge copper. An ampacity must be at least equal to the coax sheath. Yes. Must be a straight line to the grounding electrode. Yes. Grounding electrode can be any suitable type. That is acceptable. Okay. So along with my television, I should say, along with my telephone being grounded, my cable TV needs to be grounded. It's mainly worried of that line hanging between poles is susceptible to lightning strikes and surges. We need to make sure that is protected from that. And with that mentioned, with surge protections, we need to make sure we do have surge suppression in there. And actually here on our picture from before, shows you cable TV surge protection, and here is an example of one. Little surge protector, coax coming in, surge protector, coax going out, ground wire coming off of here that will be going to the ground wire at the side of your house, picking up that surge and sending it to ground. Coax cables must be run below power connectors on poles. Yep. Actually, if you look at telephone poles in your area, if you actually have telephone poles in your area and you don't have underground wiring, if you look at telephone poles in your area, the very top wires on the pole are electricity. As you come down the pole, maybe like a third, that's where your phone and cable, coax, fiber, phone cables are located. That way they are separate from the power wires. Have 8 feet of vertical clearance, and the book goes through and gives you a whole bunch of guidelines on clearances from overhangs and all that kind of good stuff. All right, nice. All right. We need to make sure we're at least 4 inches away from the power cables as we're coming in. Not interference from other circuits. Kept 6 feet from lightning protection conductors. Yeah, they give us all kinds of guidelines on where these need to be located in relationship to power lines and other things. Typically, the coax that is running from pole to pole or pole to house is a coax cable that has a messenger wire in it. And the messenger wire is there as like structural support. That's a lot of tension on this cable and this conductor if I were trying to support it with that. So this is there to take up the load of the cable and try to protect this from breaking. As we move indoor with our coax, They remind us to keep away from our power lines, our class 1 power line circuits. Can be run in the same raceway as several other types of circuits and optical cables, but cannot be in the same raceway enclosure as your power conductors or class 1. And they give us distance requirements on these too, just making sure they're staying away. We don't want to pick up that interference and that noise. They remind us a couple different types of coax cable. There is plenum riser and general purpose. In the book, they just start listing them. I tried to give you a little heads up here. When you see blah, 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 P, that's a clue that it's plenum. Blah, 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 R is riser, blah, 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 blah. If I don't have anything, it's general. And the same things apply as we talked about twisted pair. If it's installed in a plenum space, it needs to be plenum rated cable. If it's going between closets from floor to floor, floor 1 to floor 2, going between closets through that metal pipe in the floor, it needs to be riser rated or riser grade. And last but not least, just general use can be, that'd be just a patch cable going from the wall to your cable box or whatever it happens to be. That can just be general rated cable. Okay, and of course, obviously, there is price differences between these for use. You're going to pay more for the plenum rated and so forth. And last here, they remind us about substitutions, which ones can be substituted with what. For the most part, I'm going to say lean on where is it being installed and make sure you have it installed, that correct cable installed where it should be. That'll alleviate a lot of problems with inspections and building codes and that sort of thing. And again, there's a super quick overview of video with our coax lines.